them today. We did not talk about them last class, so let's do that today. There are 4 kinds of measurements in statistics, 4 kinds of measurements. I am going to start from the diagram here started from, I like to start down. So these are levels of measurement in statistics or data, levels of measurement or data. The first level is the nominal level. First level is the nominal level, actually the lowest level. That's why the arrow is going up. If it is if a variable is a nominal data or variable, categories has no order. I mean, yeah, well, even if you order them and direction, it's like a green hair, yellow hair, orange. I mean, if you're talking about, there are things you can order. Suppose you're talking about social security, the social security numbers of the people in the class, there are 30 of them. Which one is number 1? The social security does not have, it's not measured. You cannot add them, you cannot subtract them. That's why we said that they are qualitative variables. So qualitative variables are nominal variables, nominal data. Qualitative variables are nominal. Okay, so we just give you the kind. Note that nominal comes from the Latin word, the Latin word and other things. Okay, the next kind of variable is the ordinal variable. Notice ordinal is higher than nominal. Well, this ordinal data variable can be ordered. It can be ordered in categories, but still it is addition does not make sense there. It can be ordered, but addition does not make sense. Okay, when you see the word ordinal, think order. When you see the word ordinal, you say order. You can order it, but it doesn't make sense. The order doesn't make sense. Well, let's go to the third level. From the third level is interval data. You can group them. If you can group them, it's interval data. Differences between measurements, but not through 0. Okay, so if you can group them, that is an interval data. Temperature in Fahrenheit, standardized exam, so you can group them. All right, arithmetic operation can be performed in the interval measurement. Arithmetic operation can be performed, but 0 does not mean the absence of the quality. Okay, so we come to the fourth one, the last measurement of data, the ratio data. The ratio measurement, the differences between measurements are through zeros. The differences are through zeros. 3 minus 3 is 0. 3 plus 3 is 6. So when you're adding, remember that also, notice that ratio data are also quantitative. So a ratio data can be quantitative. A ratio data is quantitative. All right, so notice that nominal and ordinal will go with qualitative. Okay, differences between them can be measured. Actually, okay, so we're going to solve some problems now. Now let's go to the next definition, types of variables, putting it together. So this is another way you can see the types of variables. Okay, when you say a variable, another person is going to be thinking, what kind of variable do you need? Are you talking about quantitative variable? A quantitative variable can be interval and ratio, but discrete variable, if a variable is discrete, then it is discrete or continuous. So what you want to know is that you can combine qualitative and quantitative with levels of measurement. So here are the 4 levels of measurement. The 4 levels of measurement. Here are the 2 kinds of data. And then categorical data is the same thing as qualitative. Categorical data is the same as qualitative. Discrete or continuous is the same as quantitative. So this diagram is actually very good for the definition of variable. So what if you're told to define a variable? If you can draw it this way, that is a good way of defining the variable. We're going to look at it again. Okay, so suppose you're told to, in statistics, when you're told to define a variable, it's not enough to say that a variable varies. A variable varies. Okay, what kind of variable are you talking about? Is it a quantitative variable or qualitative variable? Is it qualitative or quantitative? If it is quantitative, then arithmetic makes sense. It's interval ratio measurement or ratio measurement. And it means it can also be discrete or continuous. So whenever you're talking about quantitative variable, a quantitative variable can be interval or ratio. It can be discrete or continuous. A qualitative variable can be nominal or ordinal, and it's categorical. Every qualitative variable is categorical. In fact, another name for qualitative variable is categorical variable. And another name for qualitative variable is categorical variable. Okay, let's go to the next slide. So we're doing some definitions now because it's really, these definitions are really important. Okay, so what is an observational study? It's an observational study. See, researchers observe or measure characteristics of the sample. So in an observational study, researchers, statisticians, they observe or measure characteristics of the sample, the sample members, but they do not attempt to influence or modify these characteristics. They just observe. So that's why it's called observational. In any observational study, the researchers observe only. They observe or measure characteristics of the sample members. They do not attempt to influence or modify these characteristics. So notice this is a definition of observational study. That's a definition of observational study. In an experimental study, you are doing an experiment. In an experimental study, you are actually doing an experiment. Researchers apply a treatment, which means you are touching, you are managing the, manipulating the object. Researchers apply a treatment to some or all of the sample members, and then observe the effects of the treatment. So in an experimental study, researchers apply a treatment to some or all of the sample members and then observe the effects of the treatment. Okay. Observational study versus designed experiment. Just make sure that you read this. Some people usually have problems with this, but if let's talk about confounding. If an observation is confounding, something is confounding, then it is too large, too extreme. Okay, it's too extreme from others, from the population. And confounding sometimes is mistakenly called a skewness or outlier. Okay, so this graph shows a strong correlation between ice cream sales and shark attack. But can we therefore say that the ice cream sales causes more shark attack? No. So this confounding means something in a test or what you're doing that is actually affecting it, and they are not even related. Therefore, causation does not even mean correlation. Causation doesn't mean correlation, doesn't mean that shark attack and ice cream are correlated. Okay, all right. When studies find an association between two things, it does not mean one thing cause the other. That's what we are trying to say in that. So we're trying to do some definitions. These definitions, they are all in your, I put the notes in the blackboard. So if you read the notes, you will see that observational studies, we just talked about that now. But it's important that you read them. So what kind of sampling methods can you use? There are 4 of them. That's one called simple random sample, which is called SRS, simple random sample. In a simple random sample, everybody is given equal opportunity to be selected. By the way, in all these sampling methods, the surveyor does not have any choice as to which individuals are in the study, thus eliminating the bias. So in any way you are trying to get a sample, make sure you are not biased. Stratified samples. So let's go to simple random sample. I would like you to read this because it's going to take us time. But notice that simple random sample is one of the methods of sampling. In simple random sampling, the members of the population are listed in any order, and each one is assigned a random number. So just everyone is allowed to be voted for. So nobody is discriminated about. Simple random sample. Equally likely, everybody is given an opportunity to be selected. Okay, so but before you start, you have to have a frame, a list of all the individuals within the population which you are sampling. Okay, so I would like you to read all those because that's a whole lot. It's going to take a lot of time. Okay, so I just want to tell you that everything you are looking for is in the notes. The notes that I posted in stratified sampling. It's obtained by separating the population into overlapping, non-overlapping groups called strata. Okay, then taking a sample from each strata. Okay, and then stratified sampling method, the principal of high school wants to conduct a survey to determine opinions regarding parking on the campus. There are 150 freshmen, 150 sophomore, 100 juniors, and 100 seniors. How would he go about obtaining a stratified sample of 60 students? So what he's going to do is he will divide this 60 maybe into 4 and get a sample of 15. Let's see how many. Yeah, about 15 from freshmen, 15 from sophomore, 15 from juniors, and 15 from seniors. So already these are in different groups. You did not make the groups, but you want to take a sample from each strata. You take a sample from each of them, and then obtaining a sample from each of the stratum. Each stratum is a singular, strata is plural. Okay, and now let's go to, so systematic sampling is obtained by selecting every kate individual from the population. For example, I can say I want to select every fifth individual in the class. And so when I count 1, 2, 3, 4, 5, the fifth person is one of the individuals. And then if I'm collecting the age, they will tell me their age, or they tell me the age, their height, and their weight. It depends on how many variables I'm collecting. So that's called systematic sampling method. Okay, so step 1, if possible, approximate the population size, and then determine the sample size, and then compute n divided, capital divided by, then randomly select the numbers between 1 and k. These are the steps I want you to read that. This is the summary of what you're doing in. You will need to know all the sampling methods. You want to know the sampling methods. Okay, cluster sampling. A school administrator wants to obtain a sample of students at an elementary school to survey about technology accessibility. How will this be done using cluster sampling? So they are clustered. I'll just go to where they are and take a sample. So for example, you can get into one class. So it says in a cluster sample, we divide the population into groups. We are the ones that will divide. So we are the one that will divide. So you are manipulating this time. Obtain simple random sampling to select groups and survey all the individuals in the selected group. Okay, so remember there are 4 of them. Simple random samples, stratified sampling method, systematic sampling method. You want to know how they are done before, and then you can, after you finish, response bias. There can be a bias when there is response. For example, if you're doing an interview and you call people at home, maybe you call A, you don't know that A is B. So the same A answers, and then also answers B. And you never know, and you're not there, so response bias can happen. There will be sampling error, there will also be non-sampling error. So please read the notes before you can, it will help you do the homework. The homework, majority of the homework is on definitions. Is there any question? Is there any question so far? Any question? All right. Asia, do you have any question? Okay. So
No,
we can.
ma'am.
Very good. So we can go to let's solve some problems. Let's get to that worksheet we started the other day, and we're going to solve some problems. So let's go to that worksheet. I want us to use our calculator again today to find the mean, median, and mode. You should be able to use your calculator to calculate the mean, the median, and the mode. One variable stat. It's important that you use your calculator to do the one variable stat. Okay, so we are going to be doing number 1. We did it I did it the other day, but that one did not show, so I want to make sure I do it again. I want to make sure that it's visible today, because it was not, for some reasons it wasn't visible. Okay, now question number 1 says find the mean, the median, and the mode of the data. Okay, we already know how to do this from elementary school, but we still want to review it before we get into what we're doing. So I would like to use the required calculator. The required calculator in this class is TI-84. So that's what I'm going to use now. I'll turn my calculator on. I am going to go to the list, one of the lists, go to Start, Edit, and I want to type in all the raw data. It is called raw data because it's not arranged in order. So I'm going to type in the raw data. 23, enter. 21, enter. 17, enter. 19, you have to type it one by one. 19, 6, enter. 4, enter. 29, enter. 26, enter. And 17, enter. Okay, when I finish, I will check to know how many, what is the count of this, how many are there? So I'm going to check. How many am I given? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the count, the sample size is 9. So I'm going to check my calculator and see. Did I actually put in 9 of them? Let me check. So my calculator is asking me for the 10th number. Therefore, I put in 9 of them. But it's not in ascending order. So I want to ask my calculator to arrange it in order. I want to ask my calculator to arrange this in ascending order. So I'm going to go to Stat, and I will arrow down to 2. And you see that 2 says sort A. Sort A means sort ascending. So I select 2. And it's asking me where is the list you want to sort. My list is in L1. By the way, there are 6 lists in this calculator, but I'm using L1 right now. So I do second L1. So I just told my calculator where the list is. I just told my calculator where the list is. So when I hit enter, it tells me done, that he has sorted the data. So let's go back and see. Is it now sorted in ascending order? Yes. So my calculator has sorted this data in ascending order. Therefore, what I'm going to do now is I want to do a one variable start of the data in L1. So I'm going to tell my calculator again, go to STAT, arrow to calc, do select number 1. Number 1 says one variable start. Note that. So you can actually click enter or you arrow to 1, but it's already on 1. So I'll select, and then it's asking me where is your list? Out of the 6 lists, where is your list? My list is in L1. Okay, if it is in L2, I'll type L2, but it's in L1. I'll arrow down. I don't have frequency. Why? Why do I not have frequency? Because this is not a group data. I don't have frequency because this is not a group data. So I'm going to calculate. So when I calculate that, I see that the mean X bar is 18. Notice that X bar is 18. They did not ask me to get the standard deviation, but if they asked me to get the standard deviation, sample standard deviation is 8.38. Notice there are 2 standard deviations. S is sample standard deviation. Sigma is population standard deviation. The sample standard deviation is almost always higher all the time. But anyway, I'm not asked to get the standard deviation, but very soon I will be asked to. So I'll arrow down. See, it's telling me that sample size is 9. So this arrow shows that there's still more. There is more. So I'm going to arrow down. So these numbers here are called 5-number summary. With these 5 numbers, I can draw a box plot. But what I need now is the median anyway. I just need the median. So I just need the median, but this is called the 5-number summary. So the first one is the minimum number 4. The second one is the first quartile. The third one is the second quartile. The fourth one is the third quartile, the maximum number. If I'm told to find the range, you know that the range is the maximum number minus minimum number. Find the range, maximum number minus minimum number. Okay? If you're told to find the interquartile range, it means Q3, third quartile minus first quartile. Okay, so first of all, I'm told to find the mean, the median, and the mode. So I've already found the mean, and I found the median. The median is 19. If I arrow up again, I will see that the mean is 18. But there is something I haven't found. I haven't found the mode. So I can go back to my data, which I sorted, and I will look for the number that repeated most. Which number repeated most? It's 17. No other number repeated, I guess. So 17 is the mode. Now, the question says find the mean, the median, and the mode. So you have to be careful. The mean is 18. The median is 19. The mode is according to the order I'm asked the question. And the mode is 17. So see here should be your answer. Be careful, because this one has also 19, 18, 17. But it's not in the order that you're all told to find it. This is the median, but you're told to find the mean, the median, and the mode. So that is not the mean. This one right here is not the median, so be careful. And this actually is the mode. But you respect the sequence. Respect the sequence you're told to use to find the problems or solve the problem. So don't just, people fail this number because they are not checking the sequence. Okay, we will go to question number, let me go to another number, and we want to actually do an example that contains everyday experience. So what are we going to do, use all this mean, median, and mode to do in real life? What are we actually going to be using it to do? How do we apply mean, median, and mode in real life? Okay, so what we're going to do is, I'm going to pull up. Let's go to question number 3. And let's look at question number 3. Okay, and this question says, the number of patients treated in a dental, see, the number of patients. So this is a real world question. I like real world question. The number of patients treated in a dental hospital, so dental office or hospital, each day was recorded for 11 days. So this 11 days represents sample size. So sample size is 11. 11 days, the recorded days. So they made a chart. Okay, find the mean, the median, and the mode. Find the mean, the median, and the mode of this data, of this recording. So the same thing I did before, I will get my calculator and I will type in all the numbers here. You remember that sample size is 11. So when you finish typing, there must be 11 of them. If you add in any extra, then that is going to be a problem. So what I'm going to do is get my calculator again and type in the number one by one. But this time I don't want to use L1, I want to use L2. In other words, I want my data to be in list 2. So the next thing I want to do is type in the numbers carefully. 10, enter. 10, again, enter. 11, enter. 18, type in the numbers carefully, because if you're going to type in 18 and you mistakenly type in 81, the game is over. You missed that number because you changed the question. So whenever it's a raw data, you have to be careful typing in the numbers in your calculator. 22, enter. 10 again after 22. 10 again. See, another 10. Then 29. 14. 10 again. 21. So I'm going to carefully look at my calculator and see what is asking me. So my calculator is asking me to put in the 12th number. Because my calculator is asking me to put in the 12th number, then I have it right. The sample size is 11. So another thing I will check is there any odd number? Is there a number? Did I put in a 3-digit? We are human beings, we make mistakes. So that's why I have to check, eyeball what number, the numbers you put in, and make sure that you did not mistakenly put in a 4-digit number there. Because suppose you mistakenly put in 111 there, okay, or 1100. It doesn't matter how accurate your calculation is going to be, you are still wrong. You change your question. And actually, you failed it from the beginning. So be careful. All right, so I see that the data I entered is correct. The sample size is correct. So I am about to find the one variable stat. I'm going to find the statistic using one variable stat. So I'm going to go to stat, STAT, arrow to calc, do one variable stat, and it's asking me where is the list. Now, be careful because the list this time is not L1. If you forget to put in L2 there, then you screwed up because your answer will be wrong. So you make sure you tell the calculator the actual list where your data is. So my data is a raw data and it's in L2. And then I'll go down to frequency. This is not a grouped data, so I don't have a frequency column. It is not a group data, so I don't have a frequency column. Then I'm going to calculate. All right, so the mean is 15. That's what it's trying to tell me. The mean is 15. Let me arrow down and see the median. The median is 11. And I am also told to find the mode. So the way I can find the mode is by sorting the data in ascending order. So mean is 15. Median is 11, so mean is 15. X bar is equal to 15. The second quartile, or Q2, is equal to 11. Okay, so now I'm going to find the mode. So to find the mode, I'll go back to STAT, and I'm going to sort ascending. And I'm sorting in ascending order. My data is in L2, so second L2, close parenthesis. I hit enter. So let's see what happened. Sort ascending. Okay, I put 2 instead of L2. See? So second L2, L2. That's the best. That's better. So now I'm going to hit enter. Second L2. That means I'm telling my calculator that my data is in list 2. Be careful because you cannot put L1 there. Your data is not in L1. Okay, now let me go to that data in L2. I want to check the number that occurs most. the number that occurs most is the mode. I already know it's going to be 10. And by the way, you can arrange it by hand like you did it, because you have already done this in middle school. So you can arrange it by hand. I'm just showing you how to do it with calculator. Maybe you did not do it with calculator in middle school. So in this class, you're required to use TI-83 if you want to. But by the way, if you don't want to, and there are 20 questions in a test for you to do in 90 minutes, you can. Some of these questions can be long that you may not be able to finish it in. So you actually need to know how to use your calculator. That's one of the things we test. Do you know how to use your graphing calculator? So that's one of the things we are testing. Okay, so now we have that the mean is 15, the median is 11, and the mode is 10. Be careful, you have to write it in order. 15, see that, write it 15, 11, and the mode. Mean, median, and mode. That's the way you write it, because you have to write it in the order you are asked to answer the question. Okay, so the next thing I want to do now is go down and answer more questions like this. But that question will be asking us about the range, the interquartile range, the 5-number summary. So I'm doing these calculations because you really need to know how to do them. Really need to know how to do the calculations. And because I have already taught this class for a very long time, I know that this is the biggest problem. Learning how to use a calculator takes time. But if you come back from work, if you work now and you watch these videos, then you won't have any problem with your calculator. Also, the author showed you how to use the calculator. So whichever one you like, you want to make sure that you know how to use your calculator either way, whether you're using the textbook or watching the videos in class. Okay, the golf score for, look at this, number 10. Let's see. Actually, they did this distribution for us. So let's see what they are talking about. I know you have read. You have already been given histograms when you were in middle school. So this is a middle school question. And so this, let me see what the question is asking us to do. Okay, so let's see. Okay, is asking us to do. So this actually is a histogram drawn for us. And how do I know it's a histogram? It's the overlap, the bars of a histogram overlap. The bars of a histogram overlap. So that is the difference. If it is a bar graph, the bars will be different. They are not going to be overlapping. Bars will be different. So we want to find the we want to know which histogram correctly shows the frequency distribution of the scores. We're not going to be in a hurry to get into frequency distribution. We shall be doing it in 3 weeks, 2 weeks or 3. But for now, let's quickly go to let's keep on doing the mean, median, and mode. And when you are given this kind of data, it is called stem and leaf display. All these data here are quantitative data. They are quantitative variable. I see that this one is actually, there's no decimal here. So I can say that this quantitative data here is discrete also. It is discrete and it is quantitative, discrete quantitative data. And which means it can also be ratio measurement. Okay, so notice that measurement levels of measurement, which is, there are 4 of them. variables, quantitative and qualitative, and then discrete and continuous variable. They're all related one way or the other. Okay, so this is called a stem and leaf display. The question could be, find the original number. You could be told to find the original number. Find the original number. Somebody has already arranged it in stem and leaf display. So all you need to check is, okay, what is the legend? What is their formula? What did they do? Round the probability to, okay, that's probability, but it doesn't matter. We can now. So we already told there are 20. Okay, but if you're told to find, so this is 52. So if you're told to list the original, see 52, 55, 52, 55, 57, 57. I'm talking about the first row. 59, 59 again. So someone can give me a stem and leaf display and ask me to rewrite it. But you know it's already arranged in ascending order. So now this is 62, 62, 62, 63, 65, 68, 69, and 69 again. And actually, they can also ask me more questions. So in the third row, I have 71, 72, 75, 75, 75. There are two 75s there. 75, 75. Okay. Okay, so now I want to finish writing that. So another 75 here, and another 78. And then the last row, I have 80, 80, 81. And someone can ask me to find what is the range. Find the range. The range is maximum number minus minimum number, the way you learned it in middle school. 81 minus 52. So the range is 81 minus 52. And if you're told to find the interquartile range, or you could be told to find the mode. So you find out which numbers repeated. So let's check. What is the mode? What is the mode? So what is the mode? Let's see. So the mode is the number that repeated most. So right here, I see that 7 repeated twice. So 7. I see that 9 repeated twice. So I start with 57, 59. I come over here and I see that 9 repeated twice. So 69, 69. And I come down here and see that 75 repeated twice. 75, 75. And 80 repeated twice. Therefore, I can now conclude that this data has many modes. This data has many modes. It's multimodal. The data is multimodal. So the first one is 57, second one is 59, third one is 69, fourth is 75, and the last is 80. So the data is multimodal. So they can ask me to find a lot of statistics from here. They can actually ask me to find the mean, the median, the standard deviation. I think we're going to start from there next class. So they can ask me to find the mean, the median, and the standard deviation. Okay, if I'm told to find the mean, the median, and the standard deviation, what do you think I can do? Are you still there? Is there anybody who can answer my question? Suppose I'm given this stem and leaf display, and I'm told to find the mean, the median, and mode, find the standard deviation, find the variance. Is anybody still in class? What do I do? Somebody already did the stem and leaf for me, and they want me to find the mean, the median, and the mode.